All right, so we're gonna look at chemical equations and law of conservation of mass today. So the one thing that you need to know about law of conservation of mass is that whatever you start with, you have to end with the same amount of those elements on the other side of the equation. So we're just gonna look at kind of the parts and stuff. We're gonna write down a chemical equation in here, and we're gonna label the different parts of it, and then we're gonna discuss just kind of how to determine if it is actually a true equation or if it's not one. So just go to the next page in your notebook. You're just gonna open up to that. And at the top of it, we're gonna write chemical equations. All right, so we'll start with the easiest one that a lot of you already know. We're gonna look at water, the chemical formula for water. So I'm gonna start with just writing out the equation real quick. H2 plus O, and I'm gonna draw an arrow, and then it's gonna end up with H2O. So when we look at this equation, we have two different sides of the equation that's separated by this arrow. And what this arrow is it means yields or produces. It kind of takes my beginning and separate it from my ending. So it's yields or produces. All right. The H2 plus O would be what we call the reactant. All right. This is where my reaction is going to take place. These are the reactants. We always say that they're what I start with. So it's my starting substances. And then I have my yields or produces. So they come together, they have their chemical reaction here, and then they give me H2O. We call that the product. Pretty simple to figure out. My product is the ending substance. So the way I like to think of this is that I take my starting substances and I put them into a hat and I shake the hat up and then I throw it out on the table and it gives me my ending product, my what I'm gonna get for the production at the end. They're not going to be in the same, oh gosh, my mind just left me, I'm so sorry, order that they were in at the beginning, okay? That's the whole point of a chemical equation and a chemical reaction taking place. I'm going to get a new substance with this, all right? So whatever happens in my chemical equation, my end is going to give me a new substance. This is called the law of conservation of mass. Now, I teach this a little different than some of the other teachers do. All right, so down here, I'm just going to go ahead and I'm going to write my formula again so I can show you how to do that. I'm going to put my beginning, my yields, and my ends. And right here where I see my yields, I'm just going to kind of draw a line straight down from that. That's separating my two parts of my equation. And then I'm going to list my elements. I have hydrogen and oxygen. I'm going to go to the opposite side, my product side, and I'm going to put hydrogen and oxygen on there. Now, when I look at my reactant side and see hydrogen 2, I know I have 2 of them. I have oxygen, there's no number there, so we automatically know we have 1 when we started. I come to my product side, H2, and then O, there's no number, so I know I have 1. I compare the 2 of these, and it's the same thing on both sides. This is called law of conservation of mass. So I'm going to write that down here. So my law of conservation of mass states that matter cannot be created nor destroyed. So I didn't create new matter over here. I took the same thing and I just had a reaction with it and it came out in a different order. So matter cannot be created nor destroyed. Alright, so I have that taken care of. Now the next thing that you're going to get is a sheet, and you might have printed it off already. Okay, what I'm going to do is I'm going to just pull up my sheet real quick, and we're going to look at it. And it's just practicing my equations. So I pulled up RM55. I'm going to start with this one. You might start with 54, but let's start with 55 for right now. All right. It gives me the word explanation. I have 1 molecule of sodium hydroxide, or hydroxide, I can't talk, reacts with 1 molecule of hydrochloric acid. So I'm looking down here at my chemical equation, NaOH plus HCl. Well, again, I'm going to take this and I'm going to do a visual model. So I'm going to start with NaO and H. So that's what I have there. Plus HCl, HCl. Alright, I'm going to draw, after I had my reaction take place, I'm going to come over here and I'm going to draw 1 molecule of sodium chloride and 1 molecule of water. So NaCl, and they have to be touching, and then H2O, and those have to touch, but they're not going to touch each other because they're 2 different chemical formulas. Now, in order to see if my law of conservation of mass and to see if my equation is balanced, what I'm going to do is I'm going to list my elements. I have an Na, I have an O, I have H, and I have Cl. And I'm going to go to my product side and I'm going to list it in the same order. Looking at my Na on my reactant side, I'm going to count. I only have 1, so I put a 1 beside it. My O, I only have 1. H, I have an H here and an H here, so that gives me 2 hydrogens. And then I have a chlorine, so I have 1 chlorine. I've got to go to my product side now, and I've got to see, do I have the same thing? Na, looking over here, only see 1. Oxygen, only see 1. Hydrogen, looking, oh, there's 2, and chlorine, 1. So since I have the same number on both sides, I can call this a balanced equation or a true equation. And I'm proving the point that what I start with, I have to have the same amount on my product side. So my reactant side, however many I have, has to match my product side for each element. I can't say I have 3 sodium here and 1 sodium there, then that's not a true equation and it wouldn't be right. All right, so it has to have 1 and 1 of however many on both sides. You're going to do RM54 and RM55. If you have any questions, just let us know and we can help you. All right, so we're going to go over your review sheet and we're going to talk about some of it real quick. My last period class is actually going to help us fill this in, so that way you can be involved in a little bit of the discussion for this. Our test is going to be on October 8th and stuff. You should have filled out the first part the past 2 days, but what I'm going to go ahead and do is we're going to help you make sure that your answers make sense to you, and that way you have it filled in. So October 8th is whenever we do the test of this. The vocabulary test will be the day before. So let's look at this. I want to start with eighth man. So I need y'all's help. What does eighth man stand for? What's the A stand for?
Atomic number.
Okay, so I have my atomic number. What's my P?
Protons.
And E.
Electrons.
Okay, what do we know about these things?
They're all the same.
Okay, they're all the same what? Same number. So if I know one of them, then I'm going to know all of them. All right, let's look at man, M-A-N. What's M?
Mass.
Mass number. What's my A? And what do I do to them?
Subtract them to get the neutrons.
To get the neutrons. Alright, so I want to look at this diagram here of an atom. Let's look at this. If I'm looking at the ones with the minus charge, what are those called? Electrons. Please be loud. Okay, then the ones with no charge,
Neutrons.
and then the ones with the plus.
Protons.
Okay, so when I'm looking at these, my middle is made up of my protons and neutrons. What do we call the middle?
Nucleus.
What's the nucleus give me?
Atomic mass.
The mass of the atom, right? So if my nucleus gives me the mass, what do my electrons give me?
Volume.
The volume, good. All right, and then I have these electrons on that outermost energy level. What do we call them?
Valence electrons.
What do our valence electrons give us? Reactivity. All right, so they give me my reactivity and my group number, or I can also say my valence electrons will give me if they're stable or not. All right. So let's come over here. What determines the identity of an element? What do we have to do? Look at the number of what?
Protons.
Number of protons. Okay, from that I go and tell my atomic number, but my protons is what gives me my element. That's what I have to count. All right, so protons, where are they located?
Nucleus.
What's their charge?
Positive.
Mass?
1 AMU.
All right, neutrons.
Nucleus.
Charge?
Neutral.
Neutral or no, so I put a 0. What's their mass?
1 AMU.
And then my electrons.
Electron cloud.
Okay, electron cloud. Oops, I was going to put something different there. I don't know what. Electron cloud, what's their charge?
Negative.
And what's their mass?
0.00055.
Okay, so when we think about them, they're the size of what?
Like a tiny little thing.
Tiny grain of sand, basically, okay?
Grain of sand in the atom.
All right, now let's look at this chart here. If I'm looking at this, how do I find, what acronym do I use to find my protons? What acronym did we use?
8.
8. What about for my neutrons? And then electrons?
8.
And then total particles. This one we struggled with on the last test. Total particles, what's that mean?
All of them combined.
All of them combined. So we're going to add all the particles together. All right, so looking at my periodic table for sodium, what's my protons? 11. If my protons are 11, what else are 11?
Electrons.
Good. How many neutrons do I have?
11.
No. 12.
Go look at it. It's 23 is what it rounds to minus 11 gives me 12. Make sure you look at it because it was, when I looked at it, what was it? 22.8, which rounds up to 23. All right, my total particles is what?
34.
Good. Silicon. How many protons?
14.
14. Neutrons.
14.
Electrons.
14.
Total.
42.
Good. Calcium. Protons.
20.
Neutrons.
20.
Electrons.
20.
Total.
60.
Ooh, we're dying off in our sound. Come on, people, talk.
Okay.
Beryllium. Protons.
4.
Neutrons.
5.
Electrons.
4.
And total.
13.
Good. Now we're going to look at density. There's going to be a couple of density problems on here. My 6th grader is actually doing density right now as we speak in science, 6th grade science. So what's the formula for density? Density equals what?
Mass over volume.
Mass over volume. All right, so as I'm looking at this, I'm going to read through my first question. It says I have a mass of 23.4 grams and a volume of 3 milliliters. Okay, what kind of shaped object is it if I'm using milliliters as a measurement? Irregular, because I had to use what?
Water displacement.
Water displacement of a graduated cylinder. Good. So my density equals M divided by V, so all I'm doing is plugging in these numbers. that simple math that tells me 23 divided by 3, my whole number, is going to be 7. Because that gives me to 21. If I did 8, then that would be a 24.4. So, doing math, I know it has to be iron. Alright, so I did that simple math real fast, and I only needed to do the first digit. From there, I'm looking for what is the density of a substance with a with a volume of 5 milliliters and a mass of 15 grams. Is that regular or irregular?
Irregular.
How do we know?
Because it's milliliters.
Milliliters, good. Density equals M over V. Again, just plugging in numbers. 15 grams divided by 5 milliliters gives me what?
3 grams per milliliter.
3 grams per milliliter. Good job.
Yeah.
All right, now down here for Bohr models, we're going to do boron. We're going to do boron as our thing. What acronyms must I have down there for this? APE and what else?
MAN.
MAN. All right, look at boron on your periodic table. What's my A for boron?
5.
If my A is 5, what else has to be 5? My protons and electrons. Good. What's my M? 11 minus what?
5.
Gives me
6.
6. All right, so now I've got to draw it. I don't want to use colors. I want to do the charges that we know. Protons, what charge are they?
Positive.
Neutrons, neutral, and electrons, negative. So I'm going to go and I'm going to just draw this in there. My nucleus, the middle has what?
5 protons.
5 protons,
6 neutrons.
6 neutrons. Question, if my protons and neutrons are different, what do we call those? Begins with an I.
Ion.
Nope. That's when my electrons and protons are different.
Oh.
Isotope.
Isotope.
Alright. I have 5 electrons. How many can go in the first string?
2.
How many does that leave for the next? 1, 2, 3. Good. Alright, how do I get the mass of an atom? How do I get the mass of this atom?
The amount of protons.
Protons plus neutrons. So I'm writing that note over here. Protons plus neutrons. Alright, how many protons do I have? Plus how many neutrons? Equals? 11 what? AMU. Good. Who hypothesized the structure? Who came up with this? Something Bohr. What's his first name? Niels.
Oh yeah, Niels.
Niels Bohr. Okay. And who came up with the arrangement of the periodic table?
Oh.
Dmitri
Mendeleev.
Mendeleev. Yeah, I can never pronounce him right. Yeah. I can spell his name, I just can't pronounce it. Alright, you can't do either. That's okay. We still love you. Alright, now I've got to do these from least to most in my mass. Which one's going to be my smallest one? Electron, because we know it's the size of what?
A grain of sand.
A grain of sand. Alright? Then, the next two are the same. Protons and neutrons. So I'm just going to write them like this. They're going to be right there together. They're the same. And then my largest mass would be all of it together, atom. Alright? So we're caught up to that. I want to work on this part here. Today is our new part. Alright, we're going to look at the periodic table. I asked you to do something with these numbers that go down the side. What do I tell you to do with it? There we go. So I have 1 energy level for 1, 2 energy level for 2, 3 energy level for 3, and I can keep going if I want to. I know that they go side to side, so they go from the right or left to right whenever I'm doing that. Left to right. So sorry. What do we call these? Periods. So I'm going to write periods down here. And you told me it meant the what?
The number of energy levels.
Number of energy levels. Alright. Then the numbers up above, what do we know about those numbers? What do we call them?
Groups of
Groups.
families and the valence electrons.
Okay, so they're called groups. You said valence electrons, somewhere in that mumble. Those valence electrons tell me what?
How many electrons are in the outermost energy ring?
Okay, what's that determine? Determines my what?
Reactivity.
Reactivity. So how reactive they are. And then if they're in the same group, they have what in common?
Similar qualities.
Similar behaviors or similar properties. Alright? So I told you for 8th grade science we skip 3 through 12 for valence electrons. So you're going to skip for VE, and I'm just going to put it right here. Alright, skip for VE, valence electron. So if it's in group 1, what do we know about group 1?
Has one.
One valence electron. What else do we know about
The
group 1?
most reactive.
Most reactive on this side. Okay. 2 has how many valence electrons? 2. 13 has 3 valence electrons. 14 has
4,
15,
5,
16,
6,
17.
7.
What do we know about 17?
It's also.
It's also very reactive.
So it's the most reactive on this side. And then 18 gives me 8 VE, but what do we know about group 18?
They're stable.
It's
They're
almost
stable
Noble gases.
or we call it unreactive also. We call them noble gases, they're stable, they're inert, unreactive,
What is one thing we call them?
full, they have all kinds of things we know about them. Alright, that whole group 18. My groups, which way do groups go?
Up and down.
Up and down.
So they're going to go up and down. So they'll just go, I'm going to draw an arrow showing going downward. Alright? Now, let's talk about these metals, nonmetals, and metalloids. Alright? I'm going to come over here and I'm just going to draw a little box. And I'm going to make mine green because, well, that's the color we used for it whenever we did it in class. But I'm going to label them metalloids. And for my test purpose, I'm going to put a diagonal lines going on it. So I just put diagonal lines right there for metalloids. Where are my metalloids found?
On that
Along the
zigzag
zigzag.
line.
Alright, except for which guy?
Aluminum.
Aluminum is not. He is a what?
Metal.
Metal. So I'm going to go through and I'm going to just do a diagonal line on this. It makes it easier whenever I study this, but it also makes it easier for whenever I get my test and Ms. Strizich makes me, do my periodic table. I can just do those real fast and label those metalloids. My next one are going to be my non-metals because that's the next one in the smallest size, and I'm just going to give them polka dots. Where are my non-metals found?
To the right of.
Okay, so I'm just going to go through and I'm just going to do a couple of polka dots on here, and I'm just going to spread it out, and I'm not going to worry about too many of them. Is that all my non-metals?
No, we have
No, we have
We have hydrogen over here. Okay, so I'm going to give them polka dots too. So I put hydrogen as polka dots. The majority of my table is made up of what? Metals.
Wow.
So all I'm going to do is I'm going to leave those blank. And now all I know, everything to that left side are metals. They don't have anything on them. I just know that they're all metals. All right, made it easier for me. Let's come down here. What are some properties that I'm going to find with metals? If I had to describe my metals, what are some properties?
They're good conductors.
Okay, so they're conductors. What else do I need?
Malleable.
They're shiny. Oops, sorry, conductors, comma, shiny. It helps if I can write. Malleable. Ductile. What else do I know? Magnetic. All right, let's talk about my non-metals. What do they have?
Dull.
Oh, they're dull.
Brittle.
They're brittle, dull, brittle.
Insulators.
Insulators. All right, what about my metalloids? What do we know about those metalloids?
They have qualities of both.
Similar to both. Depending on what group they're in is what it's going to be. So similar to both metal and non-metal. Alright, what determines how reactive an element is? Valence electrons do. Alright, so if that's true, then what groups are going to be my most reactive?
1,
17.
Most reactive 1, 2, and 17 because they lose or gain electrons really fast. Alright, let's look at this. Elements in the same group have the same, they have,
valence electrons.
okay, so I have both valence electrons I have similar properties and what else do I know about my groups? Based on their valence electron there,
Reactivity.
similar reactivity. If they're in the same period, what do they have in common?
The same amount of energy levels.
Number of energy levels. Anything else they can have in common?
Nope.
No, because some of them will have metals, non-metals, and metalloids in them, which means that their properties are going to be different. So it's only going to have energy levels. All right, number of valence electrons. If it's in group 1, how many? If it's in group 2, how many? 13, 14, 15, 16, 17, 18,
8 or 2.
2 or 8, depending on if it's helium. All right, good. All right. Next would be find the element. Group 2, period 4. Who am I? Group 15, period 6. Who am I? Bismuth. Good. I'm stable in period 4. So what's that mean if it's stable? It's in what
It's
group?
in the last one.
Group 18. Good. Who am I? Krypton. Most reactive metal. So what group is it in? Is it it's the most reactive metal? Group 1. Period 7. Who am I?
Francium.
Most reactive non-metal would be in group 17.
Chlorine.
Period 3. Chlorine. And then 6 energy levels and 6 valence electrons. Ooh, 6 valence electrons mean it's in group what?
16.
So who am I? Helium.
Oh, yeah.
2 energy levels and 3 valence electrons means it's in what group if it has 3 valence electrons?
13.
13. So who am I?
Boron.
Boron. Alright, which atom below is the most reactive? Look at these models. Which one would be my most reactive?
A.
Why?
Only has one valence electron.
Good. Atom A, because 1 valence electron. It's easy to give that one up. Alright? Which atom below is inert or non-reactive?
B.
Why?
Because it has.
It has 8 electrons.
Because 8 valence electrons, it's full. It has no room. Alright. Of the elements N, O, Cl, Na, and S, which 2 would likely have similar chemical properties? What's that mean if it has similar chemical properties? They're in the same group.
O and S.
Same group, so which one would it be?
O and S.
O and S, yes. All right, good job. We're gonna take this and put it away. Tomorrow we'll come back and we'll look at this.